Welcome, chemists, to another session on chemistry with Tanima. I'm Gambari Aminato Tanima, and today you are sure to have an amazing session on this channel because we'll be discussing what I'll call the basics of chemistry. During the introduction to chemistry tutorial, we mentioned that chemistry majorly deals with matter, and we define matter as any substance that has mass and occupies space. We gave examples of matter as literally anything we can find around us: the air we breathe in, the water we take, the food we eat, the chairs we sit on, and a lot more. Today, we will be discussing the nature of matter. But before we proceed, I want to quickly clarify something. When you say matter is anything that has mass and occupies space, it is quite different from matter is anything that has weight and occupies space. Because mass and weight are measured in the same quantity, but they have different definitions. Mass can be defined as the total quantity of particles present in a substance, while weight is defined as the force acting on a substance as a result of the gravitational pull. So it is wrong to define matter as anything that has weight and occupies space, but it is the right definition is matter is anything that has mass and occupies space. So under this topic, we will be discussing the state of matter, the properties of matter, and the changes matter can undergo as well. So let's proceed. Matter can exist in three different states based on the arrangement of their particles. It can exist as solid, it can exist as liquid, and it can exist as gas. Meaning that literally anything we can find around us are either solid, liquid, or in their gaseous form. When we are talking about the solid state of matter, it is a state whereby the particles of matter are closely packed together. They are closely packed together and they only vibrate in a fixed position. They cannot be compressed and their shapes cannot be changed as well. They usually have definite volumes as well. An example of a solid state of matter is this marker. Other examples are the stones you can find around you, the chairs you sit on and so forth. These matters cannot change their shapes and they always have definite volumes. When matter is in its liquid state, its particles are loosely packed together, which is why they can be easily poured into different containers and they will take the shape of those containers in which they are poured. They also have definite volumes but do not have definite shapes. They only take the shapes of the container in which they are poured into. But when you talk about the gaseous state of matter, take cooking gas for instance. Once you open your cooking gas in a particular room, you can perceive the smell from the other room. The major reason is that the particles move freely and independently of each other. Once the particles have moved from one room to the other room, you can easily perceive the smell from the other room. So one thing about gaseous state of matter is that their particles move independently of each other, and as a result, they do not have definite shapes, neither do they have definite volumes. So let's quickly discuss some properties of matter. The properties of matter are classified into two: the physical properties of matter and the chemical properties of matter. The physical properties of matter are those properties of matter that can easily be observed without changing the composition or through mere observation. Examples of these physical properties of matter include the color, the odor, the melting point, boiling point, density, and a lot more. But when we talk about the chemical properties of matter, these refer to the properties of matter that determine how this substance or how this matter reacts with others to form new compounds. Examples of them are their reactivity, their acidity, and so on and so forth. Most times, these properties can only be determined through an actual experiment or inquiry. Depending on the nature of matter, depending on the properties of these matters as well, matter can undergo several changes, but these changes are majorly classified into two. When you have a sachet of water, for instance, and you decide that, oh, I don't want to take this water as it is, I want it frozen, and you decide to keep it in the freezer. Do you know that after keeping it in the freezer, if you weigh the water at that time, you realize that it has the same mass as it was before you kept it in the freezer? This is because the matter has undergone a physical change. meaning that that change is easily reversible, and that change does not cause a change in mass, and that change can be classified as a physical change. So when we are talking about physical changes are those changes that matter undergo that does not result in a change in mass, that is easily reversible, and no new substances are formed from it. If you keep the water in the freezer, for instance, and you later decided that, oh, I want to have this water the way it was before, you can easily just put it down or decide to heat it up until you have a liquid form of that water back. You have changed that water from a particular state to another, but that change does not change the actual constituent of the matter. So that is what we call an example of physical change. Another example is the dissolution of salt in water. If you decide to get your salt and water back, it can easily be done through a particular process known as evaporation. We will be discussing more of these processes when we get to separation techniques. Other examples are melting of candle wax and so on and so forth. So when we discuss chemical changes, they are simply the opposite of physical changes. It is a type of change which is permanent, which is not easily reversible, and it results in the formation of new substances. Example is the burning of wood. If you have some woods, let's assume you want to make something, so you want to use firewood, for instance, and you decide to like light up the firewood. Eventually, you will notice that the wood would burn to ashes. Now, if you take those ashes, there's nothing you can do to it that will return it back to the wood it was before. So that is an example of a chemical change. The change is permanent. Rusting of iron is another very good example of chemical change as well. So with this, we have come to the end of this topic. We have briefly explained some states of matter, the properties of matter, as well as some changes matter undergo. And remember that matter is anything that has mass and occupies space. Remember to like this video, subscribe to the channel, drop your comments for me. I'm expecting questions from this topic as well, and I await your suggestions too. Turn on your post notification because there are so many more chemistry discoveries waiting to be made on this channel. See you in the next class. Till then, bye.